Okay, we'll go ahead and get going here for today. We'll let other folks join late if they're going to hop aboard. So thanks everyone for attending. Hope you're staying safe. Hope you're staying healthy. Today we're joined by Vinod Damla. He's one of our senior protocol engineers and has done extensive work committing upstream to Quorum, Besu, Geth repositories, works very, very closely with a lot of our enterprise customers, debugging a number of things, not only at the application level, but especially lower down the stack at the actual blockchain level. So we're really lucky to have him, and he's gonna talk much lower in the protocol layer than we've gone before here. So exciting to have some new content today. I just have a few slides, as I typically do, to set the table, and then we'll turn it over to Vinod for all things nodes today and configurations. So let me go ahead and flip to the next slide. So at a very high level, just defining Kaleido, built for modern business networks, very much use case, industry agnostic. We see projects and enterprises spanning finance, supply chain, government, pharmaceutical. So Kaleido is really the infrastructure, the runtime, the componentry that allows you to have a robust blockchain layer, but also have all of the other features and services that you need to build out a proper full stack solution. So completely agnostic of your industry or your vertical. The platform itself, both at the protocol level and the services level, is radically simple. We'll peel back a few of the layers today and look at some of the more sophisticated and elaborate techniques to, bespokely configure your blockchain layer. But at a high level, there is a clean API for every single feature in the product, and the console itself is very intuitive and click button simple. And then lastly, very much built for the enterprise. So HADR, preemptive auto scaling, you get all of these things out of the box on Kaleido. Our approach to projects on Kaleido is to try to really flatten the curve. So make it very easy for you to adopt the technology, not worry about crypto primitives, not worry about P2P communications, or actually having to be the administrator or the maintenance operator for your blockchain runtime. We give you all of that out of the box with a lot of techniques to further configure that. And that's what we'll look at today. And then we provide you with the confidence to transition into a pilot phase, decentralize your network, operate with shared IT ownership, and then ideally transition into production, spanning your network across the globe on different clouds, and even perhaps running your nodes on premise with transactions and throughput running at scale. One of our approaches and one of our insights into standing up a lot of these enterprise projects is that the blockchain is only really 5 to 10% of the overall solution. And in the past, we've talked about all of the different layers that go into a full stack solution. We talk about the data, we talk about the transaction layer, we talk about the connectors and the data feeds and middleware, and then we talk about the application layer. Today, we're actually going to focus on that 5 to 10% because it is incredibly important. That's your trust anchor, that's your source of truth, and that's what you're going to refer to if you ever get into a dispute or you have litigation. And we're going to focus specifically on a lot of the edge cases and a lot of the configurations that you might need to implement to really optimize your application and your network. So that's what we'll focus on today. Just a quick snapshot of a few of the customers running on Kaleido, and we can see that this really does span all verticals and all industries. We see energy majors, we see huge financial institutions, government, finance, retail, entertainment, you name it. All of these customers, all these companies are running in production on Kaleido. And I'll mute my WhatsApp here in just a moment. Sorry about that. And then lastly, just touching on a few of the enterprise features of Kaleido. So ISO 27001, 17 and 18 certified, tons of techniques around key management. We've touched on these in the past, but we'll resurface these on an upcoming Tech Tuesday. X509 identity constructs built into the platform at the organizational level and at the blockchain level as well. Best of breed open source technologies, node clients and algorithms. And then, as I mentioned, HADR, backups, business continuity. You get all of this out of the box with Kaleido. And then there's just the last thing I'll touch on. We are a standard software as a service model where you can pay as you go, essentially bear the cost for the hourly runtimes of your nodes and services. But we also like to meet our customers at the appropriate stage of their project. So whether you are in sandbox or development, or whether you're getting closer to a pilot or an MVP, we have custom packages where we can give you time-boxed access to all the resources, all the configurations, and all the services that you need to, in a quick little window, build out a very robust project that you can ultimately transition into production. So I'll leave my email in the chat and we can talk commercials or use case details offline. Happy to share any more information about all those. So that was my table setting for Kaleido. I see we've had a number of people join as I was diving through these slides. So great timing to all the newcomers. And I'm going to turn it over to Vino now, who's going to touch on a lot of really exciting things and a lot of the configuration options that we have here in Kaleido around nodes and around environments. And I think he'll even share some insights and some stories about working with customers and some of the edge cases and some of the problems that they've run into. So without further ado, I will turn it over to our senior protocol lead, Vinod.
Thanks for the introduction, Nick. Hello, everyone. Thanks for joining. As Nick introduced me, my name is Vinod Damle. I work in the protocol engineering team at Kaleido. If you've opened support tickets with Kaleido in the past, you've probably seen or hear me chime in on those support tickets. I also deal pretty heavily on most of these support tickets, especially with having to do on the blockchain runtimes. And as Nick mentioned, I've also contributed to the upstream projects and keep a close tab on what's going on in those projects. So I'll cover a few areas today because we have the entire hour. I think I'd like to begin with talking about one of the key aspects of the decentralization model within nodes in a blockchain in Kaleido, which is to do with block signing. And we'll go over the details of what that means, how nodes participate, and how you can change the status of a node from being a signer to a non-signer and whatnot. In Kaleido, we've also automated the process of having nodes be signers. So the next thing I'll be walking over is a quick demonstration of the automated service and how to set it up to have your nodes as signers and have it rotate across all the nodes in your chain. The third thing I'd like to talk about, which is a recent and a very exciting addition, and this has been mainly via support tickets in the past, but we are excited to have this feature of advanced blockchain and node configuration. Not all customers, have a suited need for the defaults which Kaleido presents when creating an environment or a node. And we definitely allow you to customize your environment or node beyond the defaults which are in place when you create an environment. Lastly, if time permits, I'd like to touch upon a few things which have been some of the support high runners. These are things which are pitfalls or which users typically tend to hit when using nodes in Kaleido to deploy their contracts and transactions. So let's get started with the first element, which is around block signers. So let's jump straight into a running environment and a node. And one thing you'll see if you dig under the hood and start looking at the logs is there are all these messages about the nodes saying, hey, I queued a propagated block. I tried to propose a block. Let me try to, yeah. So this message here says, I signed recently, I must wait for others. And in some cases, you will see, hopefully soon, yeah. So here it says, I successfully sealed a new block and so on. So what does this really mean in the context of a permission blockchain? Now, in public or the Ethereum mainnet, I'm sure all of you have heard the term miners and how there are designated nodes which are responsible for producing blocks, and they are incentivized with some cryptocurrencies in order to spend the amount of effort which is required to compute the nonces and propose or to cut those new blocks. So in a permission setting, the process of producing blocks is decentralized and it's distributed among all the trusted participants of the node. So in Kaleido, when you're creating a node, if you've noticed, there's a small checkbox that says make this node a signer. Now, what that really means is when you create the node as a signer, then it has the ability to propose blocks among the different participants in the chain. So the way blocks are created in a permission blockchain is every node which is a signer has its turn to propose blocks, where it's basically packaging all the transactions which are in its work queue, and it creates the block in the standard format, and then it proposes it for all the other members to see. Now, the other members are able to, or the other participants are able to verify that this block was created by the node that claims it has created the block, because there's signatures for the node which has proposed the block, and all the other signer nodes get to vote on the proposed block. Now, when I say voting, there's obviously a threshold in terms of when a block gets accepted. And the threshold is actually different between consensus algorithms. I'm not going to dive deep into the consensus algorithms themselves, but just know that there are separate thresholds for clique POA, which is the standard proof of authority consensus, and the quorum version of Istanbul BFT consensus, or the Besu version of the IBFT2 consensus. So once a node proposes a block, it shares it or broadcasts it to all the other participants in the chain. The other signers vote on the block or on the block proposal. And once a threshold has been reached, then that block gets accepted and becomes what is known as the canonical block in the blockchain. And the blockchain obviously advances. Now, how do the nodes as signers change over time? Now, that's the second aspect of decentralization, basically. So the number of signers or the list of signers in a chain can also vary over time, and that is also done via voting. So nodes which are signers get to vote on either new nodes being added to the signer list or existing nodes being removed from the signer list. So along with producing or packaging transactions into a block, a node can also vote for another node to be added or removed into the signer list. Now, these votes also get captured into a block as it's produced. And when a block is produced, every node goes and looks at the existing votes within that block to see whether there are, hey, any new votes for a node to be made a signer or removed a signer. The votes are obviously tallied by every node. And once a threshold is reached, which is again based on the consensus algorithm, a new node is either added to the list or removed from the list. So I mentioned earlier about creating a node as a signer. So let's look at an existing environment. So I have 5 nodes in this environment. And if I were to create a new node here, you will see, so I don't want to create any configurations yet, which we'll walk over later. So in the final step where you're picking the node size, there's also this small checkbox that says make this node a signer. This is the default setting in Kaleido, but you also have the option of making a node a non-signer if the sole purpose of the node is to just sync blocks and be able to look at all the transactions or accept newer transactions. The other reason why you would want to make a node as a non-signer is environments with very large nodes. Now, because of the way consensus algorithms work, there's upper bound to the number of nodes which can be signers, because signers have to exchange messages among themselves in order to tally votes, in order to propose blocks, and all of that good stuff. So because this is like a fully meshed network in terms of message exchange, in Kaleido, we limit the amount of nodes which can be signers in a single environment to 16 based on some benchmark testing. So if you have an environment with a very, very large number of nodes, then you basically have to pick and choose which nodes become signers and which nodes become non-signers. This is obviously not a problem in smaller environments, and you can pick all the nodes to be signers if your billing plan allows for it. So once we make a node as a signer, the other nodes, based on the orchestration framework we have in Kaleido, get notified that a new node is being added, and they also see that this node is being added as a signer. So those other nodes basically vote for this new node based on its consensus identity so that it gets added to the signer list. So while this node is coming up, let's go back to the main screen here. And we now have in the new environment a blockchain dashboard, which shows the state of each node and the role it's taking part in the consensus algorithm. So you can see here that all of the nodes here were created as signers, including the Kaleido system monitor. As I said earlier, the system monitor is created as a signer by default in Kaleido. And you're probably aware that in an Ethereum blockchain, there's the concept of a Genesis block, which is block 0. And the Genesis block has a list of signers, which is set about in the block. Now, in Kaleido, when you create an environment, the system monitor's consensus identity goes into the Genesis block as a signer. Every subsequent node which is added as a signer gets voted by the existing signers, which means the first node which is added gets voted in by the system monitor, and subsequently the other nodes which are added or removed get voted in or voted out by the existing nodes which are signers. So we see that a new node has been added here, and it is also a signer. The Kaleido API, which is Nick, can you see my Postman, or am I only sharing my Chrome right now?
Yeah, no Postman at the moment.
Okay, so maybe I should stop sharing and restart with the entire screen.
Yeah, we'll dig into some of the more advanced API calls here. And folks, if there are any questions, feel free to just throw them into the chat or raise your hands, and we're happy to address those in real time. Yeah. Looks good, Vinod. We can see it now.
Okay, thanks. So as you can see, I have an API request here being made to the node, querying its status. So if I invoke this API again, we see in the response a list of current validators or signers, which is returned by the node. Now, this is actually a query to the node's get runtime. So this data is updated based on what's currently on the runtime. So this is not something which is stored in a Kaleido database or something like that, but this is on-chain, most up-to-date information. So as you can see, this is basically a bunch of hex strings, which corresponds to the consensus identity for each node, which is part of the signer list. So if we look at, so just to show you what those hex strings mean, if we look at the node overview for any node, we see that there's a consensus identity here. And what you can see from this list is that particular consensus identity is part of the signer list. So whenever we change a node from a signer to a non-signer, there will be voting, which is captured in what is called the current proposals, which is also something that gets documented in the block. And after a successful tally is carried out and a suitable threshold is crossed, then the signer list is updated on the chain. So what I'm going to do now is go to an existing node. So let's start with the system monitor. So many of our customers have asked us in the past, hey, look, the Kaleido system monitor is something which is a node that's maintained and monitored by Kaleido. It's the blockchain access point for Kaleido. we prefer that the system monitor is not a signer node. So we added a feature to change the consensus role of the system monitor from a signer to a non-signer. So I'm going to change this to a non-signer. And this basically indicates that Kaleido will orchestrate the changes which are required to make this node a non-signer. So let's go ahead and say apply. And you see here that the role changed to a non-signer. And if I refresh this API status now, so we see that one of the proposals changed to a false, which means all of these nodes, and we can go and query all of these nodes, which I'm not doing. I'm only querying one of the nodes in the environment. And this node is saying, hey, look, I voted for this particular node's identity to be voted out of the signer list. So we still see 7 entries in the signer list, but if we wait for 1 or 2 blocks to be mined, which is basically 5 to 10 seconds, because I'm looking at a get POA environment, and I refresh the status again, you see now that there's only 6 entries in the current validators, because the monitor node or the system monitor node was just voted out of the signer list. So similarly, we can go ahead and vote out some of the other nodes depending on how we want to configure our environment. Just know that every consensus algorithm has a lower bound for the number of signers which must exist in the chain. This is for reasons of stability, because the consensus algorithm is designed to operate on a certain number of nodes being offline or in a failed state. So these APIs to vote in or vote out a node make sure that the lower bound is not breached when you, for example, remove a node as a signer. So for Clique POA, we mandate that the minimum number of signers is 3. And for Quorum IBFT, the minimum number of signers is 4. Similarly, for Besu IBFT, it's also 4. So if you're trying to remove one too many signer nodes, then we flag an error. But basically, this is how you would change a node from being a signer to a non-signer. Now, just a quick point before we wrap this up. So we went to the blockchain dashboard to change the system monitor status from being a signer to a non-signer. But if we want to change a particular node that is created by a customer, then we will go to the node and its settings panel, where there are a multitude of options in terms of what you can do with the node's administrative actions. And over here, you'll see an option to change the node to a non-signer. We can obviously do this as well. And we query the status, and we see that one more node has been voted out in the most recent round. You'll see the old proposal still hanging out, because that's a feature of the consensus algorithm. There's a certain time or epoch during which these votes are still maintained in the block, and they get cleared out from time to time. Anyway, that's a feature of the consensus algorithm itself. So refreshing it in a minute, you see, well, in a few seconds, you see that the number of signers has now come down to 5. So any questions so far in terms of configuring your nodes as signers or non-signers?
Hey, Vinod, I think I'll just toss a softball in there. Maybe it might be interesting for folks to just hear about the difference in terms of the consensus identity between Geth proof of authority configurations and IBFT configuration. Just the fact that we're using the Ethereum account on Geth, and we're using a different key. Yeah,
that's a great point. So in Geth POA, yes, so this is a Geth proof of authority environment with the Clique consensus. So in the Geth proof of authority consensus, you will see that the user account address, which is the default account which is created on the node, and the consensus identity both match. This is by design. And what we are doing essentially is the node's default account is also used as the identity for signing blocks. So you see that the consensus identity and the user account is one and the same for Click POA. But for IBFT in Quorum, it's slightly different. There is definitely a default user account even for IBFT, but there's a separate key pair which is created and is used just for signing blocks and for use in the consensus when when a node is talking to its peer nodes. So if we go to an existing Quorum IBFT environment, yes, so I have thankfully an environment which is Quorum IBFT. And over here, you will see that the node's default account has an address which is different from what is the node's consensus identity. So when you're referring to the signer list on the node, or when you want to remove a node or add a node as a signer via the API, you definitely want to use the consensus identity for the node and not necessarily the user accounts or the user account address. This works if it's Click POA, but to be sure, it's best to use the consensus identity, which is a separate, or which could be a separate address in certain cases.
Great.
So how do customers maintain this, especially in large environments where I said we limit the number of signers to be at 16 in order for consensus stability reasons? So at Kaleido, we created an automated service called Rotate Signer Service. The Rotate Signer service is not yet added into the new dashboard. It's in the process of being added in. So let me go back to the old console to demo the Rotate Signers real quick. So in this environment, I'm going to choose the option to add a new service. So we can see here that there are 6 nodes in this environment, including the system monitor. And the Rotate Signer service allows for you to say, hey, I want to maintain a specific number of signers in this environment. And we'll see that shortly. So we scroll down until we find the Rotate Signers. So we want to add the Rotate Signer service to the same region. And okay. So I didn't create this environment to be a Click POA. So one thing is we allow for the Rotate Signer service to be created only for the Quorum IBFT consensus algorithm. So what I'm going to do here is create a new environment on the side to be a Quorum IBFT environment, and we'll come back to the Rotate Signer service after looking at some of the other aspects, so we don't have to keep waiting for the nodes to come up. So I think I can do the portion of creating an environment real quick. If any of you have questions, I'm happy to answer that while we are waiting for this.
And if folks are interested in learning a bit more about sort of the nuances of IBFT and the chattiness of the algorithm and the number of voting rounds and the need to enforce that logical cap at 16 signers, I'd encourage you to take a peek at our documentation and also at our blog. Our blogs page as well. You can access all of those very easily, just kaleido.io. There's a learn more and a resources section at the top, and you can easily navigate to the docs and the blog. And Vinod and some of the other protocol folks have expounded on some of those edge cases and some of the lower level networking details and ramifications of what can happen if you do exceed 16 validating nodes, and ultimately what can happen to the algorithm. Essentially what you're going to see is, it's very multi-threaded, as Vinod was talking about, all these nodes needing to ping each other and needing to talk to each other. And once you once you basically get to this 18, 20, 30 validators in IBFT, you're more or less going to suffocate that algorithm. And there's much more articulate explanations of precisely what's happening that are detailed by folks that are smarter than me. But if anyone is interested in kind of the lower level networking details, there's a further explanation in the docs and in the blogs as well.
Cool. So while we are waiting for that environment and the nodes to come up, the next thing I wanted to talk about was the ability to now customize an environment and also customize nodes as you're creating them. So this feature is an early preview right now. It's in our internal development environment. We expect to make this publicly available in our upcoming release, which should be, I think, slated for end of next week or the week after. But yeah, this is an early preview, soon to be available. So just that caveat while I'm demoing this. So while we create an environment, one of the things which is, or a few things which may be of interest to some customers is the ability to configure things like the chain ID, the block period, and also to pre-fund accounts in the Genesis block. So previously, all of this used to be only via the API. And in this iteration of the release, we are adding all of this functionality into our console as well. So it's readily available to a majority of our users. So as you can see, when creating the environment, soon after you pick the provider and the consensus algorithm, we now have a section below which shows the advanced configurations, which are obviously optional because Kaleido generates a chain ID automatically, and it designates a block period based on the consensus type, which is typically the most suitable for that consensus. And we also pre-fund one account with 1 billion Ether, which can be transferred from that account to other accounts later on. But in some cases, customers might wish to pre-fund accounts in the Genesis config. So all of that is available, from the get-go. So we allow you to input a chain ID if you feel the need to do so. It could be for tracking. It could be for some other internal tooling dependency you might have in your organization. The other aspect is block period, and the block period is of importance to some customers who say that we want a certain throughput and frequency in terms of transactions, and so lowering the block period for IBFT, for example, because the IBFT default block period is 10 seconds. Some have chosen to lower that to something like 5 seconds. And for Click POA, the default is 5 seconds. We now allow you to set the block period to anywhere between 5 and 10 seconds. So this is also an option, and it's typically for purposes of throughput and wanting to see blocks at a certain cadence, which might depend on the use case. The next thing is adding pre-funded accounts. So I'm going to add a set of Ethereum addresses. So I'm just picking an easy set of Ethereum addresses, which was already available on my screen. There's no specific reason I'm picking these addresses except for convenience. And obviously, the reason why you would want to pre-fund accounts is because you may have some well-known addresses in your environment which need to be set up with a certain amount of currency from the start.
And just to remind everyone, by default, and I think Vinod touched on this, but by default, every environment comes bootstrapped with 1 billion Ether, imaginary Ether. It's worth whatever you want it to be worth in an orchestrated, authenticated permission network. But that's held on the system monitor default user account. So Vinod's demonstrating a technique where maybe you have existing, key pairs, existing wallets that are managed externally, and you want to bootstrap your environment with those as the stewards of your Ether pool, essentially.
Sure. Thanks, Nick. So we've created the environment with the customizations. So let me walk you through the process of creating a node also with some customizations. So the node we are going to create here allows us to, so the console allows us to attach some cloud configurations right now, which is, maybe you want to designate a backup for your node because you want to, configure periodic backups. So similarly, we have a bunch of cloud configurations available. But once you create the node, you also have the ability to attach a custom protocol configuration to the node. And I think in the final version, which will be out as a public feature, we are looking to see if this can be added during node creation as well. So right now, there is no existing protocol configuration which exists in the environment. And the protocol configuration is basically like a node profile or a customization profile, which is created at the environment level and is available per membership. And once a protocol configuration is created, it can be attached to any of the nodes which are present within that membership. So let me go ahead and add a configuration. So one of the main reasons for creating a configuration is to want to create an archive node, and we'll walk through that use case shortly. So you can see various configuration parameters which we allow you to set. The first one being the gas price, which typically does not hold a lot of value in permissioned blockchains because there's no concept of miners incentivized by gas in order to include transactions in a block. But if for some reason you want to create a node with a gas price threshold, this is the way to do it. The second one is the target gas limit, which is the upper bound for the amount of gas which can be packed into the block, or the amount of gas which can be consumed by the transactions which are packed into the block, which dictates the size of the block. And you want to set the gas limit to a reasonable threshold, a reasonable upper bound, because you want to be able to mine all those transactions within the block period. So let's say our block period is 5 seconds. So we want to ensure that we are able to mine all the transactions which need to be included in the next block within the 5 seconds. And how do we make sure we are able to mine all those transactions? By setting a reasonable target gas price limit. Because if we set a gas price limit which is too high, then that means there's a much larger number of transactions which can be mined or included into the block. There's another factor which influences how many transactions can be included into the block, which I'm omitting right now. But if any of you is interested, I'm happy to dive into that detail as well. But this sort of think about this as an upper bound in terms of how many transactions can be included into the block, because every transaction consumes certain gas, and you can only have the aggregate of all of those transactions within the block. If you want to enable controls over which origin hosts can connect to the RPC and WebSocket endpoints on the nodes, you can obviously set CORS origin hosts. By default, everything's allowed, but we also let you customize it to certain custom domains. The verbosity of get logs, you can configure the verbosity level to be appropriately set up for your node. By default, nodes run at the debug log level, and obviously it can be tailored as well. It's slightly different for different consensus mechanisms. So for Besu, the default is info, and for the other providers, it's at debug level as the log level. So the aspect that I'm looking to demo here is the archive node configuration. So what does an archive node buy us? So in Ethereum, you probably heard of something called a state trie, which is basically a historical state of all the accounts and all the smart contracts. And by default, Ethereum nodes have a feature called state pruning, because the state database is different from the blockchain database. So if a node were to maintain state for every block, so each block itself has an associated state trie. And if a node were to maintain the entire list of state tries across all the blocks, then obviously it's going to consume a lot of storage, and it's computationally intensive as well. So by default, nodes are created as full nodes, which is typically sufficient for most of the use cases. But if you were to have a use case where you need to go and query the state of a particular contract at block, I don't know, 10 or 15 or 20, when you're currently running at block 1 million or currently running at block 100,000 or whatnot. So mainly if you want to go and query the state of an account or the state of a contract, much before in history, chances are that you will need an archive node, because Ethereum nodes typically prune the state after a certain number of blocks. I believe that threshold is set to 128 because that's typically most of the use cases. So when you want to go and query the state of a contract, or when you want to go update the state of a contract, you do not need an archive node. So it's only for things like, if you want to run a data explorer, or if you want to run some kind of an offline data caching service, which goes and looks at historical states, chances are you will likely need an archive node. So currently, archive nodes are only allowed for large Kaleido nodes. So if you set an archive node and apply it to either a small or medium node, it's ignored under the hood. It does not apply as a setting. So you want to create a large node in order to create the node as an archive. So once we create this node as an archive, so if we go back to this node which we created, and you will notice this node is a small, so we definitely want to change it to a large before we apply this configuration. So let's go ahead and edit the protocol configuration. So firstly, I think I want to change the node to be a large node. So I'm going to change the size to be a large, which I think immediately resets the node, which is fine. And then in the next step, I'm going to apply the protocol configuration. Now note that the application of the protocol configuration also requires a node reset, which is basically a restart of the node's runtime. So there's a slight amount of downtime in applying a node configuration. So let's wait until this node moves to the started state before we reapply again. And in the meantime, we see that this environment isn't started, so we can go back and check that soon after.
So Vinod, while we're waiting for that large node and that VM to come up and all those containers, there was a question in the chat about Kaleido. Does Kaleido support cross-client network? And I imagine the crux of that question is, can I have a Geth and a Quorum node running inside of the same environment? So do you want to speak to that real quickly and why that is or is not allowed?
Right. So nodes in Kaleido cannot be set up as, or environments in Kaleido cannot be set up with cross-client nodes. So say, for example, one node is a Geth, one node is a Quorum, and so on. The main reason being, in permissioned blockchains, we talked about consensus algorithms. And because we have algorithms which are different between, so let's say, for example, a Geth POA is just a proof of authority consensus. A Quorum IBFT is an IBFT consensus. So one of the main reasons why you can't have cross-client or diverse clients within the same environment is because you would then have to run the same consensus algorithms across the different clients. And today we do not have that capability within the clients. So I guess in the future, if we have different clients which run the same exact consensus algorithms, and there is a strong customer need to support it, I guess we could, probably think about that as well. But today, that's not a supported use case.
Great, thanks for that.
So this is taking longer than expected, probably due to underlying resources. So let's go back and look at the rotate signer service while we are waiting on that. So we want to add a new service. Oops, got signed out.
So as Vinod is deploying this rotate signer service in the IBFT environment that he created, just to touch on the actual large nodes, it's a very I'll use the term large. It's a much larger VM allocation than a small or than a medium node, and you get a lot of performance benefits from a large node. Namely, they're fantastic for very broadly horizontally scaled applications where you're going to need a lot of concurrent connections. Think of you have a mobile app, for instance, and you have hundreds or maybe thousands of end users, and you maybe aren't using a load balancer, and you have all these connections coming in directly into the node. And you need to support not only those concurrent connections, but also high throughput. Those large nodes are perfect for those circumstances. They're going to be able to not only allocate a portion of their CPU to the processing and the mining of transactions, but they'll also be able to use the other portion of their CPU for all of those connections, whether it's an invocation or whether it's a client connection just for a query at the blockchain. So those are available only on our business and our enterprise tiers. But as you transition into what we'd call the production or the very serious MVP phase of your project, those are worth looking into for throughput and performance considerations.
Okay, so I'm going to switch back and forth. Sorry about that, but we have this node which is now up. And I'm going to attach the archive node configuration. And I will attach this runtime, which is node 1. And if I go back to this, so one thing to note is that after attaching the protocol configuration, the node needs to be reset in order for that configuration to be applicable. So I'm going to reset this node. And once it comes back up, the node will be running in an archive mode. So the other thing which we did is customize some accounts with Ether in the Genesis config. So we could go back and attach to this node and get the balance of those accounts, and we'll see that the balance on those accounts is basically whatever we created, right? So in the interest of time, I'll probably jump to the other topics because there's a few things which I think would be beneficial to users. So the rotate signer service has started. So what you'll see in the rotate signer service is you can configure the rotation schedule, which is basically when nodes are voted in or out, and you can configure a target number of signers. So in this environment, I created six signers, and here I'm going to designate that I want the target number of signers to be 4, which means I want to rotate 2 nodes in and out at every interval, or that's I guess in the initial interval, but later on the number of nodes you want to rotate in or out is again to your choosing. You might say I want to rotate only 1 node for every interval, or you might want to say, I have 25 nodes, so I want to rotate, I don't know, all the 6 nodes in every interval. So that's a choice based on your use case, but we allow, the number of nodes you're allowed to rotate in or out. The algorithm is simple. We say that the node which has been a signer for the longest time gets voted out the first, and so on. So it's round robin with the oldest out first. So I'm going to activate this service, and so the first voting will not occur until 5 minutes after I activate this. So we'll again move on to something else and come back here to look at the status of the rotation. But you will see here that what's up next in terms of the nodes which are set to be promoted or voted out, and you will see a list of the current active signers on the dashboard as well. Moving on. So one thing which, and this was a great suggestion from Nick, given that, I constantly encounter customers, hitting some scenarios or pitfalls when using their environment. Nick suggested that, hey, why don't we talk about some of the common use cases and some of the common modes where, customers maybe trip or, maybe find it a little hard in terms of deciphering what's going on. So I gathered a list of, few use cases which are among the high runners in terms of our support tickets. The first one I'd like to talk about is, hey, why is my transaction not getting mined? So there's basically a few reasons why transaction may not get mined. And one of the main reasons is because the nonce is incorrect. So as you know, when a transaction is submitted to the Ethereum chain, we include what is called a nonce, which is basically the number of transactions which have been submitted from the account using which we are submitting the transaction. So let's take the example of this node, which I was using before. Okay, so I have a node here, so what I'm going to do here is look at its user account, and I will submit a transaction which is intentionally got an incorrect nonce so that I can simulate a use case where there's a queued transaction which is not getting mined. And we'll look at how to spot that in the dashboard as well. So the first thing I'll do is go to the Geth console. And the way to attach to the Geth console, as you're all aware, we provide a RPC URL to a node, which is protected by application credentials. So, once you have the application credentials, you can construct a RPC URL, which can be used to attach to the node. So if you attach to the node, you have the ability to get the transaction count via the RPC call eth.getTransactionCount. So I'm going to say, give me the transaction count on this particular account address. And the value currently reads 6. So which means the next transaction that I should submit from this node, from this particular account needs to carry an appropriate nonce. So what I'm going to simulate here is using one of our open source tools called Kaleido Go, which is basically a tool in order to drive transaction load to blockchains. So this is an open source repository which is written in the Golang programming language. It's available for anyone to use, so feel free to use it in order to drive your blockchain loads. There's a README and there's a help, which is useful in order to use this tool as well. So right now I'm using a simple storage contract to drive transactions with the sender account as the one which we just saw. And I'm going to simulate a use case where I'm going to intentionally set the nonce to be incorrect. So where I'm setting the nonce, the starting nonce to be 8, which is obviously wrong. So this tool is now saying I sent a transaction with a receipt, and it's going to wait for the transaction to be mined. And it's now saying that the transaction was not mined. And if we look at the nodes metrics panel, so we see that there's now one queued transaction. And the reason why this is queued is because that has an incorrect nonce. And if I were to supply, so this said, it failed because the nonce was incorrect. And if I'm supplying the correct nonce here, well, so I should be supplying 6 because we sent 6 accounts, we sent 6 transactions from the account. Nonces start with 0, which means the nonce here is expected to be 6. So we'll see here that after sending the transaction with the correct nonce, these transactions should get flushed and should all get mined into the chain. So the transactions have now moved from the queued list to the pending list, which means they'll get mined in the next block, which is mined on the chain. If we go back to the environment dashboard and to the data explorer, we will now see that there was a block with those 3 transactions, and I'm still running the tool in the background, which is why we are seeing that the block explorer is showing transaction counts increasing as newer blocks are getting mined. So this is basically either a nonce too low or a nonce incorrect kind of use case. So I guess we are running towards the end of our time. So I see a question in the Q&A which says, can the size of the transaction pools be tuned? So the answer is yes, and it's tunable in terms of picking the node size. So Kaleido allows 3 different node sizes to be configured, and as Nick was mentioning earlier, one of the other aspects of different transaction sizes, other than just the amount of active connections and the requests per second, is the transaction pool sizes. So these are different between the different nodes in order to account for how many transactions can be processed on those particular nodes based on the size. So we allow, or we set appropriate TX pool limits on different node sizes. So if you were to pick a large node, it comes with a higher transaction pool limit. And if you were to set, or if you were to create a small or a medium node, that limit is obviously smaller.
Yeah, that's awesome. Thanks for that, Vinod. So I know we're at the top of the hour. That was a ton of content, and I think that was really useful to me. So hopefully that was useful to other folks as well. One thing I just want to reiterate: we've looked at the REST API gateway, in a lot of detail in the past. But one of the things that it removes is it's going to remove a lot of those gotchas around sequencing and around nonce management. Vinod's example there was something where, similar to using a Web3 library, where inside of your server app logic, you're going to need to make that get transaction count API call in order to, receive the, accurate integer and then increment it appropriately. One of the great advantages of using our REST API gateway submission is it removes that from the table. So you can just asynchronously stream your transactions into our ETH Connect layer, and then all of that Ethereum logic is built in for you. So it removes potentially some of these edge cases where you can get queued or stalled transactions as well. So back to Vinod for the conclusion here.
Yep.
And thanks for all the questions as well.
Yep, thank you. So just one more minute. So we left the rotate signers configured and activated. So you can now see that there's now a list of signers which are active, and it shows a list of signers which are up next in terms of what's going to be rotated in or out. And we can see that, there's a last rotated timestamp here, and this should obviously, change every 5 minutes in terms of the signer list and nodes which are being added or removed from the pool.
Awesome. Well, thanks for that incredibly thorough and comprehensive demo on all things nodes and environments, Vinod. Appreciate everyone for attending. Next week, we'll be digging into some of the additional Kaleido tooling beyond Kaleido Go. Namely, we're going to look at our integration with Truffle Suite. So Truffle is fantastic for not only application development, but specifically unit tests against some sophisticated or elaborate smart contracts where you really want to exercise all of the methods and make sure that they're behaving exactly as you expect they are. So we'll dig into some of the functionality of Truffle, and we'll actually be joined by a handful of folks on the Truffle team to talk about some of their new development, some of their new features they've added into Truffle, and we'll try to provide some fresh content. I know it's probably been close to a year since we've really peeled the covers back on Truffle. And then the following week, we'll be looking at some new announcements and new features that are coming into Kaleido. So I'll just tease those, but won't really give a ton of details. But they'll be incredibly exciting and very, very important for specifically for enterprise use cases as well. It's around deployment orchestration. So thanks again, everyone, for attending. Big thanks to Vinod for taking some time out of his day to do this. And the recording will be sent out, slides will be sent out, and we will be sending out details on the upcoming talks as well. So thanks again to everyone, and hope to see you next Tuesday as well.
Thanks for your time, everyone.